Hello everyone. Yeah. Hope you had a good cup of tea or coffee. So, as Sudhir mentioned in his presentation, that we need to think from the attacker's perspective. So, I'll start with that note only. Now, imagine you are an attacker. Then, what would be the smartest way to infect maximum end users? By targeting the developers, right? After all, they are the ones who create different kinds of applications for your system and your phones. Now, suppose a trusted developer unknowingly infects the code base of an popular app's code base, right? If the update is pushed and millions of people download it, so just like that, a malware can spread. Seems scary, right? So today we are going to talk about the malware which has that kind of capability. So instead of targeting end users, it targets developers. Hello everyone, I'm Anant and I'm here with my colleague Anurag Bohra. And today we'll deep dive into a malware family that impacts macOS platform and its app creators. So XCSSET is a macOS malware family that came into light in 2020. So it doesn't heavily rely upon the typical user downloads or usual phishing attack techniques. Instead, it hides itself into an Xcode project configuration. So whenever you build such kind of project on your system, your system gets infected. So what is Xcode? Xcode is an integrated development environment, that is an IDE, used for building applications for your Apple devices. Just like we use Visual Studio, PyCharm, NetBeans, etc. for other purposes. As Xcode is used for building the applications, developers are the first set of victims for this malware. Though there is no concrete evidence about its supply chain attack involvement, but it definitely had that kind of capability. That is why it is considered as one of the severe threat. Now, why did this catch everyone's attention? From its very first appearance, it followed a very highly modular approach. So it means there were a lot of modules from its first appearance. So some of the key modules that were included in its first variant are browser hijacking, 0-days exploit to steal the browser cookies, encrypt the files on the local disk, and most importantly, infect the other Xcode projects present on the devices. Most of the modules are script-based, like it use shell script, Apple script, JavaScript, and sometime back it used Python also. What this malware set apart from the other macOS malware is its stealth capability. Like most of the modules are downloaded into memory and executed from there itself. And even if any file is created on the disk, it deletes it immediately. In the recent variant that we found that it excessively used the obfuscation to hide its code, and it also scrambled its module names. What is obfuscation? So obfuscation is a technique to hide the original data or transform it into some unreadable or ununderstandable format, so that it helps the malware to evade from the security tools, and it also makes researchers' life difficult. So we also observed that some of the modules are under development, and few modules were during our analysis we found that few modules are updated in very short time. So in short, XCSSET is a malware that is highly evasive, it is developer focused, highly modular, and as well as it is continuously evolving malware. Let's see how it evolved over the time. It all started in August 2020 when Trend Micro found this first variant. Though there are a lot of modules, but this was the first time that Xcode projects were used for infection for spreading. A year later, Kaspersky found some another hashes that were designed for the next version of this macOS, that is Big Sur, and there were also some modules which were supporting the Apple M1 chip that was released in the same year. A year later, Sentinel-1 found that it was removing its dependency from the Python 2, as macOS was planning to remove the support for the default support for the Python 2.7. So it won't be installed by default on the system. So it wants to survive, and it adapted itself to that macOS changes. And in the January of this year, we found another variant that was excessively using the obfuscation, and it also introduced some of the new persistence and infection methods. Let's take an overview about how this malware works using an attack kill chain. Suppose you have an infected Xcode project. So whenever you build such kind of project, the shellcode inside the Xcode project configuration, that is a PBX file, PBXproj file, it gets executed and it connects to C2 and downloads the next stage payload. The next stage payload again downloads the third stage payload, that is again a shell script. After some pre-checks and setting up some environment for the next stage, it downloads the Apple script, and this Apple script is the responsible for invoking different kinds of modules, like setting up new persistences, stealing the sensitive information from the system, and it was also able to infect the other Xcode projects present on the device. So how we found this new variant of this malware? So our researcher found during a routine telemetry hunting, we found that this process command line, which seemed interesting, and we started digging deeper. So you can find there are decoding instructions at the end. So after decoding, we found a simple curl request. So upon executing this curl request, this server sent an additional shell script code which had a new curl request. So this was downloaded into memory itself, and it was executed from there. Here you can find an additional information. Here you can find an additional information about what kind of malware it has to be downloaded, and we found this pattern across different stages and modules. In this third stage, it checks what kind of version that Xprotect is installed on the system. So Xprotect is an inbuilt antivirus on macOS. So there are two ways to it uses to get this information. One by using Xprotect command line, Xprotect version command, and other by reading the info.plist file inside the Xprotect bundle. So let's say if the version given is greater than 5287, it informs the C2 about it, and it simply exits, because it might be having, or it was trying to hide inside that before that version only. After that, otherwise it will continue its execution and stop all the OSS script processes running on the system. OSS script generally invokes the Apple script, or it uses executing the Apple script. It also removes the other indicators from the system, which were if there are any prior infection there. So further, it downloads an Apple script into temp directory. Then it uses the OSA compile tool to convert this Apple script into an application. After that, it uses a PL-util, an native utility, used to change and setting inside the info.plist, that is LSUI element key. Enabling this key means you can execute whenever that application is executed, it runs in the background, and your application won't be visible on the dock. And once it is executed, it clears all its files created during this stage. Let's see how this Apple script looks. So this is the Apple script that we found in the fourth stage. You can see there is a lot of obfuscation, but there are decoding instructions at the end. After decoding 7 layers of instructions, we found this original Apple script. And at the end, you can find this repetitive boot function is called. It contains, or it takes first parameter as an input. Here the module names are scrambled, Before this variant, all their module names had some meaningful names like replicator, telegram, or something. Let's see how this boot function works. So there are 3 major code flows for this boot function. The default, it will just connect to C2, download it, and execute it. If the module passed is related to targeting any specific application, it just checks whether it is installed or not. Then only it connects to C2, download it, and execute it. So there is a predefined list of Finder modules, which we are going to see soon. So if that past module is present in the Finder module, then it will download that module. Then it will call the launcher app. And once this launcher app is executed, it cleans up all its artifacts. So to explain about this launcher app and other capabilities of this malware, let me launch Anurag.
Hey everyone.
Mic 2.
Hello. Yep. Okay, so firstly, why the name launcher? It's because this application is responsible for launching few of the most critical modules of this particular malware, such as the Git-based persistence, the data file exfiltration module, the Xcode project infector, etc. Now, this app is also important because it does the setting up of all the access and permissions that these module requires before finally executing it. So this module also has like multiple filters to choose the most appropriate fake application that needs to be created. Also, if we see that it has chosen a very sneaky path for its file creations. It also maintains the logo of the legitimate application in order to disguise itself. Now, in the case of terminal, as you can see that it creates its app in the /applications folder, whereas the genuine one is present under the system's application folder. Now, something similar is observed for the Finders app too. Now, let's examine how this particular application works. So firstly, it creates a fake application, as we saw in the previous slide. After that, this application is responsible for executing a hidden script under the TMP directory. The main purpose of this script is to check whether the user has access to the user directories or not. Now, this is done by executing the listing command, which is the ls command, which will necessarily prompt the user to allow or deny the access request. Now, let's consider the case where the application gets all the permissions. So in that case, it proceeds to execute the main module, which it downloaded in the 4th stage. But in the case where it fails to obtain the permissions, it simply creates an error file and returns an error code of 403. Now, in the parent function, upon receiving the code of 403, it enters an infinite loop to reset the TCC database of that particular application. So TCC stands for transparency, consent, and control. Now, this is one of the protection mechanisms present in Apple, which basically limits the application to access various sensitive information, such as services like camera, a microphone, a location, etc., as well as the directories such as pictures, desktop, documents, etc. Now, as you can see in the video, it will keep prompting user to click on that allow button until unless it gets the access. So as we know, this particular malware has a bunch of capabilities and modules. In this section, we will examine few of the key ones, which ranges from having different methods of persistence to its info stealing capability, which includes stealing digital wallets, browser extensions, system information, data file, and lastly, we will examine how it infects the Xcode projects, where it has the capability to infect both the project archives as well as the directories. So firstly, let's talk about the persistence mechanisms. So persistence is a way through which the adversaries can maintain access to your system. It can also be used to survive system reboots as well as the log-offs. So one of the most common method in Apple, which the previous variant of this particular malware also used, was the use of launch items. However, in this particular malware, it uses 3 different mechanisms in order to maintain access to the system. Now, before we look into each of the persistence mechanism, let's check the common payload generation function, which all these module or all these method uses in order to maintain access. So in this case, firstly, it selects a random C2 address from a predefined list, after which it chooses the encoding/decoding method, which is either base64 or x60. After that, it chooses a random number between 2 and 5. Now, this number basically determines the number of encoding/decoding that this payload needs to go through before being finally returned. And at the end, it returns the final payload, which basically consists of a curl request to download and execute another script from the C2 server. Now, let's examine the first persistence method, which makes use of ZSHRC configuration file. Now, this configuration file belongs to the default shell of macOS, which is ZSH. Through this method, the adversaries can ensure that every time a new shell is created, the persistence payload executes. So for this, it's being generous because it has a global variable where it firstly checks whether to go for persistence or to remove its prior artifacts. If it proceeds for persistence, it firstly gets a payload body, which we saw in the previous slide. After that, this payload is then appended to a hidden file present under the temp directory. And after that, the final payload, which basically consists of the existence and the execution of this particular hidden file, is appended to the ZSHRC file. Now, let's look at the second persistence method, which makes use of doc. The doc is the bar which we saw, which we see in a macOS system at the bottom, where we can access the applications. Now, for this, it modifies a legitimate application or the legitimate entry of an application in doc. So for that, it firstly downloads a doc-util binary from the C2 server. Now, this tool is responsible for managing the doc items, such as adding, deleting, or updating entries. Now, after that, it basically creates a fake launchpad application. And lastly, it uses this doc-util binary to basically modify the legitimate entry of the launchpad application with this fake one. Now, let's look at what this particular application does. So it has two tasks. Firstly, it executes a legitimate launchpad application, basically to disguise itself. And secondly, which is its main motive, is to execute the main persistence payload. Now, third, which is the last persistence mechanism that it uses, is the use of the pre-commit hook file of Git repositories. Now, this one is interesting because it can basically run a script before you finalize any commit. So it makes it a very useful indicator for the adversaries because it can be used to achieve persistence, to create backdoors, to infect repositories, etc. Now, in the case of XCSSET, it firstly searches for all the Git repositories that is present. After that, it checks for the existence of the pre-commit hook file, and if it does not exist, it proceeds to create it. And at the end, the persistence payload is then appended to this particular file. Now, one of the most important questions for any malware is what's its purpose? Like, what's the motive of this malware? Now, one of the key motives of this particular malware was its info stealing capability. So in this section, firstly, we will look at its capability related to the browser data. So under this section, it has two submodules. The first submodule firstly retrieves a path list from the C2 server. Now, based on the path specified, it seems to search for various cryptocurrency digital wallet extensions across browsers and their directories. Now, this information was primarily determined by looking at the identifiers which belong to the extensions for wallets like TronLink, MetaMask, etc. Now, there was another module which basically lists down all the browser extensions that it finds installed in the system. Now, again, the browser list includes browsers like Google Chrome, Opera, Microsoft Edge, etc. Now, at the end, the data from both of these modules is then exfiltrated back to the C2 server. Now, let's look at another interesting capability, which involves stealing nodes from the system's nodes application. Now, you must be wondering, why steal nodes? It's because these nodes often store very sensitive information, such as the financial data, the corporate data, or the personal data. And I hope not, but sometimes the credentials too. Now, let's examine how it works. So firstly, it creates a fake application which executes a payload, which is something which we saw for the other modules too. Now, in this case, this payload is a JavaScript payload, which has multiple tasks. So let's examine like how the payload works. So firstly, it connects to the system nodes application to retrieve all the nodes. And for each node, it begins the processing where it gets the data, such as the body of the node, the title of the node, the creation, modification of the node. And now each of these data, or the data of each of these nodes, is then stored in an individual HTML file. And at the end, the directory which contains all these HTML files is archived and exfiltrated back to the C2 server. Now, saving best for the last, where the malware tries to become the developer too. Now, let's look at one of the most sophisticated method, or one of the most sophisticated module of this particular malware, which basically defines how it infects the Xcode projects. So as we saw in the previous slide, it has the capability to infect both the Xcode project archives as well as the directories. In case of archives, it firstly downloads a 7-zip tool from the C2 server. After that, it searches for all the .zip files which are present, which contains the Xcode project directory. And for each of the archive, it processes to unarchive them and searches for the pbxproj file, which is a project file of that particular directory, inside that directory. Now, after locating the pbxproj file, it begins to infect it by adding the payload to it. Now, in the case of directory, the process is something which is very similar. It's just that it does not involve the use of archives. So over here also, it firstly searches for all the Xcode proj directory which contains the pbxproj file in it. And after that, it appends the payload to this particular file in order to infect it. Now, if you see over here, the reason why we say it's sophisticated and it's interesting is because for this, it has multiple strategies to choose. Now, these strategies basically, and it has multiple handlers for each of these strategies, which basically defines how and where on the persistence, the infection payload will be stored in the pbxproj file. Now, with interest of time, let's look at one of the infection mechanism. Sorry, I'm stuck with persistence. Now, let's look at one of the method of the force strategy, basically, which we found to not be blocked or documented before. So over here, it creates or it defines a variable under the build settings, which will contain the main infection payload. Now, if we look closely, this payload resembles a lot to the one which we saw in the stage 1. After this, it creates a shell script phase, basically which will make use of this particular variable to execute the infection payload. So coming to the end, we have seen how this malware works, how it spreads, to how it infects, to what are the different methods of persistence it uses, to its info stealing capability. Now let's look at how you can protect your own castle. So firstly, it becomes extremely crucial to monitor and inspect all the Xcode projects that is downloaded from the external sources. But again, we are human, and it can go unseen. So here are a few of the activities that you can consider to monitor. So firstly, is if you keep getting the repeated prompt to basically allow or deny access to the user directories, which seems very unintended, now that is something which is extremely suspicious and definitely should be looked into. Secondly, if there is any unintended modification done to shell configuration files or Git repositories or Xcode projects, that is a good indicator to monitor. And thirdly, if there's an increase in network traffic which is arising through the curl process whose parent is OSS script. Now, these activities does not necessarily mean that your system is infected by this threat, but these are few of the ones basically to consider to monitor, to stay vigilant on, and basically to protect your own system. Yes, and thank you.